let's get it on. All right, go ahead and work this warm up out, and we'll talk in a minute. All right, so pause if you're not ready. Other than that, let's get rolling. Find the unknown measures for the parallelograms. All right, well, JK, if I want to know what JK is, well, if it's a parallelogram, it's identical to, what is that? JKL. I think that's an I. I don't know. HIJKL. Yeah, I. So LI. So it's going to equal 15. And the measure of angle J is going to be supplementary to the measure of angle 71, or the measure of angle I. So it's going to be 180 minus 71 is what, 109? And then measure of angle L is equal to the measure of angle J, so it's 109. This isn't meant to be super hard. KL is congruent to JI, so it's going to equal 21. And the measure of angle K is equal to the measure of angle I, so it's going to be 71. See, lots of information we find out from just a couple givens. Awesome. Write it down if you need to, but let's move on. We're only going to have 2 theorems for this lesson, but really 1 theorem today and then 1 theorem on the next day this is taught. But before we get there, I want to talk about the golden ratio. It's kind of a cool thing. Rectangles and golden ratios. So we're talking about rectangles today. And rectangles and golden rectangles in particular, are found everywhere, both in nature and constructed objects. Properties of these golden rectangles make them visually pleasing and efficient. So what is a golden rectangle? Well, look at it. You're going to kind of see it right here. This is how you construct a golden rectangle. We're going to take a square. We're going to cut it in half, draw that diagonal. Use that to make an equal measurement. And you just keep repeating that process all the way down. And where do we see this in nature? Well, first it makes this kind of cool spiral. Gets hung up a little bit. We see it in shells. We see it in lots of places. One of the main places that you see it every day is in people's faces. I mean, not with masks on now, but the golden rectangle, or this golden ratio, is actually the greatest determining factor in what we perceive as beauty is mathematical, because it's this golden ratio symmetry. So what is it? It's the ratio of 1 to 1 plus the square root of 5 over 2, which is approximately 1 to 1.618. And it is represented by the Greek letter phi. This little weird kind of looks like a O with a, goes around into a P. You can find natural examples of the golden rectangle in the spiral of a hurricane, the structure of a nautilus shell, proportions of the human face. Architects use it to balance design and structure. It's in the Pantheon, Taj Mahal, Eiffel Tower, probably in the design of your home. So it's really everywhere. It's kind of a crazy thing. Rectangles have huge applications. Now, on to our vocabulary. What is a rectangle? It's simply a parallelogram with 4 right angles. Nothing difficult. All right, what do we want to know about a rectangle? It is a parallelogram with 4 right angles, but here's what we also know. All 4 angles are right angles. Opposite sides are parallel and congruent, right? Opposite sides are parallel and congruent. Opposite angles are congruent. In fact, all the angles are congruent to each other. But the consecutive angles are supplementary. Remember, consecutive means like DC or AD, just angles touching each other, consecutive. And the diagonals bisect each other. One extra thing, so we all knew that. That's all properties of parallelograms in general. But what we also know is that in addition, the diagonals of a rectangle are congruent. So they don't just bisect each other, they're the same exact length in a rectangle. So diagonals of a rectangle, that's theorem 7.13. If a parallelogram is a rectangle, then its diagonals are congruent. And symbols, if a parallelogram is a rectangle, diagonals are congruent, right? So we know that MK is equal to JL, or congruent. Okay. Oh, I should have said posit. You can always back up a second and posit if you need to. But let's talk about what does this give me. So let's look at this TV. You may not know it, but the size of your TV is actually measured by its diagonal. So let's look at this. Televisions are typically advertised by the length of the diagonal on the screen. So if you have like a 42-inch TV, it's saying the diagonal length is 42 inches. If ST equals 21, so let's write this down. I know ST is 21. And PQ, so PQ, that's this distance right here, is 40 and 29 over 32. And we know that PTQ, so PTQ, this angle right here, is 113 degrees. Find each measure. Well, what is TQ? Well, TQ should be, remember, diagonals bisect each other, so it should be the same as ST, correct? Because this distance right here is just the same. I need to get a different color so we can see that a little better. So TQ is the same exact thing as ST, which means it's going to be 21. PR, what is PR? Well, PR is the same as the entire SQ, and since SQ is just 21 plus 21, or 42, we know it's going to be 42. And then what's the measure of angle QTR? Well, QTR is this angle right here, and it is supplementary to PTQ, so that means I should be able to take 180 and minus 113, and I get what, 67? Boom. There we go, 67. That's how we solve these out. Perfect. Pause if you need to. We're heading on. Not really a long day by any means. Okay, so we're going to use this property again. All right, let's get our stuff out there. If MO equals 2x plus 6, that's the whole thing equals 2x plus 6. And I know that in P, this whole diagonal, is equal to what? 6x minus 15. Then what is NP? Well, what can I do? I can set them equal to each other. So I'm going to have 6x minus 15 equals 2x plus 6, because the diagonals of a rectangle are congruent. And I'm just going to stay with the black here. And what I'm going to do, let's go ahead and subtract 2x over. And if I subtract 2x over, I might as well add 15. Six x minus 2x is 4x. It's gone. Equals, it's gone. 21. Okay? So if that's true, we're going to have divide both sides by 4. And we're going to have 20. I'm just going to leave it as 21/4, but it could also be x equals 5 1/4. You can have that, but I'm going to leave it as 21/4, okay? It's going to be more useful. So now I need to plug that in to 6x minus 15. And I'm going to be able to get the length of NP. Let's do this. I'm going to have 6 times 21 over 4. No. There we go. Minus 15. Which is going to change that to 2. That's going to be what? 3, because 2 goes into both those. 3 times 21 is 63. So I'm going to have 63 halves, which is just what? 31.5? And 31.5 minus 15 equals 16.5. So we know the MP is 16.5. All right. Take a look at that. That should be a 6. I'm going to erase it here in just a second because I got to make room for our next problem. So again, that's 16.5. What do I have over here? The measure of angle NOP. Let's see, NOP is 2y minus 3, and MOP is y plus 12. So this is y plus 12. And the original, I didn't write it down, is 2y minus 3. There's a couple ways I could approach this. We do have a theorem that says if there's even one right angle, they're all right angles. So what I'm going to do is I'm going to say, all right, I know 2y minus 3 is equal to 90 degrees. It has to be, right? That whole NOP, it's that whole angle, it's 90 degrees. So let's do that. Add 3, add 3. I get that 2y equals 93 divided by 2. And it's going to be what, 46.5? I'd much rather deal with decimals. Okay, so if that's what y equals, let's plug that back in to y plus 12. I'm going to have 46.5 plus, so I'm plugging it in because I know that angle MOP, which is this angle right here, is going to be 46.5 plus, what does it tell us, plus 12, which is just what, 58.5? Okay, so now if I know that this is 58.5, then what do I got to do? All right, well, here's what I'm going to do now. Are you ready for this? I'm going to erase that. I'm going to erase all this. If this is 58.5, how do I get, what I really want now is just this purple angle right here. It says NOM. So I want just this leftover NOM right there. So how do I get NOM? Well, I'm going to take 90 and subtract 58.5. So let's do it. 90 minus 58.5 90.0, right? Got borrow 10, goes 9, that went to 8. It goes 10 minus 5 is 5. 0.9 minus 8 is 1. 8 minus 5 is 3. That's 31.5 degrees. So it is 31.5 degrees. Boom! Right there. All right. This is it for today's lesson. Go back, pause, fast forward, whatever you need to do to get through this. If you have any questions, always email me. Send me questions. With that said,